Hello, everyone, and welcome to the NAGT webinar series. The NAGT webinar series is your one-stop shop for strengthening work in Earth education. Webinars in this series feature novel and innovative work in Earth education, research and pedagogy, new teaching materials, and the classroom and professional experiences of people like you. The NAGT webinar series is free and open to the public, and we encourage you to invite your colleagues to attend and join the discussion. On the screen is a link to the webinar series where you can find the webinar schedule and an archive of past events, and as well as information on our sponsoring projects and programs. You can find slides, resources, and a recording of each webinar, including today's, through the webinar archives. If you can go to the next slide, Vince. Please take a moment to review the Zoom controls on the screen. We ask that you please leave your microphones muted and videos off. This will help us get a good recording of today's webinar. If you have questions and comments that you'd like to add along the way, we encourage you to enter those into the chat box. To access that, find the Zoom control bar and click on either the chat button or the more button and then on chat. Webinar presenters and moderators will be monitoring the chat for any questions and comments that come in there. Today's webinar is titled Sneak Peek at the new edition of the AGI and NAGT Laboratory Manual in Physical Geology. And we'll hear from the author-editor, Vince Cronin, who's professor of geosciences at Baylor University. Vince will share insights into the new edition of the lab manual, including a new chapter, new activities, and other new or improved resources, as well as ways that you can adapt the lab manual for your classroom. And with that, I'll turn things over to Vince.
Okay. Well, thanks to everybody for dropping in. I'm a longtime member of NAGT who has had the privilege of editing the AGI NAGT Laboratory Manual in Physical Geology these past 5 years. So let's take a sneak peek at the new edition. The 12th edition of the lab manual is now in print and available for adoption. I've got my very own copy of it on the table right next to me, so I can tell you for certain that it exists. The new edition of the lab manual is available as a spiral-bound paper version, an e-text, and as a customized text that you can design to meet your course needs. And there's an instructor's edition as well, or an instructor's manual, and that's there to help you. It's got the references for all of the background material. It's got helpful hints, it has answers and so forth. There's also a version of Mastering Geology for use with the lab manual. So I'm talking about the revised lab manual in this webinar because I place great value and importance on both NAGT and AGI. You might not know this, but both organizations benefit financially from the sale of this lab manual, which is published by Pearson. And I think it's a great educational resource that meets the needs of many who teach introductory level physical geology to undergraduates. And a lot of people helped with the creation of this lab manual, in addition to the fine team from Pearson. At the top of the list, of course, is Dennis Tossa, whose geoscience illustrations have defined the pinnacle of the art for decades. Ed Robeck and Mark Carpenter of AGI were essential partners to bring the 12th edition together. And around 4 dozen other geoscientists contributed reviews, comments, and resources for this edition. So today I speak on behalf of a team of folks who worked very hard and care very deeply about this lab manual, as well as the organizations that it supports. This lab manual has always been unique in 2 important ways. It was created and is maintained by the geosciences community as a community educational resource. Its evolution over the past 34 years has been a joint effort of the geoscience education community led by NAGT and AGI. Proceeds from its sale provide substantial financial support for the work of NAGT and AGI, which benefits the entire geoscience community. I cannot overstate the importance of this. NAGT and AGI receive the royalties from the sale of this lab manual. Now, the idea for a nationally published lab manual for undergraduate physical geology courses originated with Robert Ridke, a past president of NAGT, while he was serving as an AGI Education Committee member. He envisioned this book as including the best laboratory investigations written by geology teachers. Indeed, the new edition represents the cumulative efforts of more than 225 contributing authors and countless faculty, students, and geoscience professionals who have offered reviews and constructive comments since the first edition was published back in 1986. Richard Bush edited most of those editions. 3.5 decades after that first edition, the AGI NAGT lab manual is used in hundreds of different schools, including large research universities, four-year colleges, community colleges, and even some high schools that have geoscience courses. It's used where there are dedicated teaching labs with lots of maps and specimens, as well as in distance learning situations where everything a student needs to complete the lab is provided by the lab manual and associated internet resources. My view is that the lab manual provides a strong framework of good geoscience content around which I can build an effective lab experience for my students. And when I have used it in university settings where lab teachers are also students, the lab manual provides consistent quality regardless of the language skills, background, or teaching abilities of the student teaching assistants. Now, some of you haven't seen or used the lab manual before, so let me give you a brief overview. Each chapter of the laboratory manual has two parts: an introductory part with text, photos, and graphics that provide students with information they'll need as they complete the lab activities. The introductory part functions as a complete and coherent textbook that provides context and content for the lab activities. The second part of the chapter is comprised by the lab activity sheets that are printed on perforated pages intended to be torn out and submitted to the grader at the end of each lab session. So after the activity sheets are torn from the lab book, the remainder of the book is still a useful textbook about the topics studied in the lab. Indeed, some teachers use the AGI and NAGT lab manual as the only course textbook that they require students to buy. Each of the 17 lab chapters in the 12th edition has at least 4 different activities, and most labs have at least 6 activities. Overall, there are 105 lab activities in the lab manual. I usually assign 4 or 5 activities per 2-hour lab session, and frequently assign lab activities as homework in the lecture section of my course. Many of the lab activities are intentionally designed so that they do not absolutely require access to physical specimens, lab instruments, or other apparatus. And so these lab activities are particularly good for use in distance learning. So what's new or different in the 12th edition? The part that I'm most excited about, of course, is a new lab devoted to climate change. This is a topic that has been represented in several chapters in the last few editions, but the new 12th edition devotes an entire lab to climate change, with 6 new activities supported by 4 new videos. We'll take a look at the new climate change chapter a bit later. With a lot of help from Mark Carpenter at AGI, we've included a greater and more explicit emphasis on Earth system science in the 12th edition. Helping students to understand our planet in terms of Earth's major interacting systems will be a continuing effort in future editions. We have 17 new or significantly revised lab activities throughout the manual, and we'll look at some of this material later. A hallmark of the AGI NAGT lab manual over the years has always been its great photographs and clear illustrations. We have over 100 new photographs in the 12th edition, the vast majority of which are either public domain or created at no cost for this project. So the addition of great new photographs does not increase the cost of the lab manual, although we hope that it enhances the value of the lab manual to students. The next 4 slides are examples of new photos created using focus stacking. The process of focus stacking involves taking between 10 and 30 separate photographs of each specimen and then merging them together to achieve great depth of field and focus throughout. So here's a new photo to help us define conchoidal fracture. Dr. Elizabeth Petsios, an invertebrate paleontologist who happens to speak Greek, helped us to understand that the tiny ribs on the surface of the fracture reminded early geologists of the curved growth lines on the curved surface of some cockle or mussel shells. The ancient Greek word for mussel shells is konkouli, from which the root word konch is derived. So we put a common mussel shell in the photo to kind of emphasize that connection. Here we used a very serious macro lens on my camera to image rounded quartz, not rounded quartz grains, to take a look at some itsy bitsy teensy fossils embedded in sedimentary rock. The field of view is perhaps 5 centimeters wide, and it gives you a really good feel for how rich the fossil record can be in some instances. Here we use a very serious macro lens again in my camera to image rounded quartz sand grains as an example of a clastic texture that's then compared with in this very same figure with the mass of intergrown crystals in this igneous specimen, a granitic rock. We're trying to continue the tradition of great specimen photographs from earlier editions. Dennis Tassa provided about 150 new or revised graphics to the 12th edition. We did a lot of work improving the scales of maps in this edition so that they would be easier for students to use. And we put learning goals at the beginning of every activity, in essence to answer the student question, why am I doing this? One of our new activities replaces the previous first activity in the tectonics lab. The new activity introduces some of the different reference frames that we use to describe the motion of plates. We start with a simple map of 2 ridge segments and a transform fault between the North American and African plates, patterned after the Atlantis transform fault. While this looks very cartoonish, those 4 points are accurately located relative to the actual plate boundary. So the first reference frame involves motion relative to the plate boundary itself. Students are asked to draw arrows indicating how each plate will move relative to the boundary. And so there it is. So far, so good. On the next page, students clip out a map of the Atlantis transform derived from GeoMap app and based on multi-beam seismic surveys of the seafloor. The map is in the lower left part of the page. Students then use the 2 pieces of the cutout map to help them understand how this plate boundary works. Here, motion will be shown relative to a different reference frame that is external to the lithosphere, something like the hotspot reference frame. Here's the base map that students will put their 2 puzzle pieces on. The locations of the points on this map were determined using a modern quantitative model for the finite motion of plates. First, we locate the North American plate where it will be in 2 million years. And then we do the same for the African plate. The gaps indicate the areas where new lithosphere will be created by seafloor spreading, and there will be shear displacement along the transform fault. Based on this geometry, students are asked to predict where the active plate boundary will be in 2 million years. And there it is. The use of manipulatives in this activity will help a lot, I think. One of our new activities involves revising a legacy activity last seen in the 10th edition. This is based on the classic work of Vincent Matthews, whose 1973 paper correlated two halves of a Miocene volcano that was split by displacement along the San Andreas Fault. Students are asked to determine distances and rates for the separation of these two halves. The other component of that activity in the 10th edition involved the use of GPS velocity data across the San Andreas Fault in Southern California. We've updated the figure with GPS site velocities measured relative to the stable interior of North America. The data are from UNAVCO and were current as of February 2019. Students can seek more current data from the web resources that's listed right there in the caption. In the Minerals Lab, we created or adapted activities so that they more directly address the properties of minerals that we use to identify them, such as luster, diaphaneity, color, streak, habit, cleavage, and hardness. Here, they view photographs of 7 specimens and determine whether each displays a metallic or a non-metallic luster. When I had the opportunity for face-to-face teaching, my students examine actual specimens. We hope to develop some 3D virtual specimens for students involved in distance learning to manipulate in the future. Here, students work on characterizing opaque, translucent, and transparent mineral grains. In part C, they observe the different colored streaks or powders of 5 different minerals: yellow, green streak, red-brown streak, dark gray streak, and white streak. Now, I'd tell you what minerals those are, but you never know, maybe a student will get a hold of this webinar, so let's just keep it our little secret. In the upper exercise, students examine 8 types of minerals that usually occur with a specific color or a narrow range of colors. In activity E below, well, this should look familiar to anyone who used a previous edition of the lab manual, but we've added another color to the set of quartz specimens that indicate that some minerals occur in several different colors. Here, students examine crystals that developed with characteristic habits or growth forms that, like the snowflake, reveal information about their inner structure. The new snowflake photos were donated by Professor Ken Librecht of Caltech for this lab manual. Then students move on to consider the shapes that mineral grains take on when they're broken, their cleavage or fracture. In short, we've reorganized a couple of activities in the Minerals Lab to place greater emphasis on important physical properties that we can use to identify minerals, while retaining the extensive tables of mineral properties that have been part of the lab manual for decades. We added a simple flow chart for identifying a mineral specimen. This is the first of several new or revised mineral and rock identification tables that are in the new edition. We have 2 charts to help students differentiate between the major igneous rock types that are traditionally included in an introductory physical geology course. To identify a given specimen, students start by characterizing the percentage of mafic minerals, or color index, the types and abundance of minerals, and the texture of the rock. This chart includes small photographs of minerals and textures. A student starts with the previous chart to compile a list of observable properties, and then moves on to this chart for the tentative identification process, again, using color index, minerals, and texture. The sedimentary rock ID tables include categories for organic solids, peat to coal, carbonate rocks, silicic and siliciclastic rocks, and an other category for rock salt and rock gypsum. The metamorphic rock ID chart has a three-step identification process and includes information about likely protoliths and how we use the rock. Anthracite coal makes an appearance in this chart by popular demand. I want to show you another new feature and a useful detail. A few activities were thought to be useful for future geoscience majors, but perhaps a little bit too detailed for our non-geoscience friends. These activities are identified with purple lettering as digging deeper items, with a little icon of a slice through earth by the title. This particular activity from the Igneous Rocks Lab gives students a chance to simulate a point count for identifying an igneous rock and to use some simple counting statistics. In the 11th edition, Dennis Tassa and I created an opaque blue layer with a grid of holes in it and literally placed that holy layer over the mineral map that you see in panel B up in the middle right part of this page. The result in the 11th edition was this illustration. Students were asked to estimate the percentage of each of the four colors that might be visible in a given hole in the grid and to tally up the totals for the whole grid. Now, to a geo nerd, this is a pretty fun challenge, but to more normal humans, well, this was just crazy making. So now the colors have been summarized for each hole into quarter, half, three-quarter, and whole circles of color. This is substantially the same information, but it is much easier to tally. There's a new activity in the Igneous Rocks Lab that asks students to map the different rock types that are characteristic of 25 different active volcanoes around the Pacific. The table containing the necessary information is given below the map. We want students to discover whether there is a relationship between the tectonic environment and the type of volcanic rocks that are found there. This activity involves subduction of oceanic lithosphere under both oceanic and continental lithosphere, as well as hotspot volcanism on oceanic and continental crust. And backed by popular demand, although I must say at the disappointment of a number of actual igneous petrologists, is a graphic and accompanying text about Bowen's reaction series. We worked very hard both on this illustration and the text, so I think it will be useful. Possibly a more useful graphic along the same lines was provided by Alan Glazner, showing the range of crystallization temperatures for some of the same rock-forming minerals that Bowen included in his chart way back in 1922, almost a century ago. John Tabor and our friends at IRIS are helping us with the Earthquakes Lab. This new version of an old graphic is a plot of the vertical seismogram from a 2017 earthquake in Mexico. So we're looking at real data here rather than an artistic reproduction. This new graphic is constructed from a stack of 17 seismograms from that same earthquake in Mexico, showing the P, S, and surface wave travel time curves. The idea is that we did not just dream up the travel time curves from some model of the Earth, but our models are based on real empirical data. This revised activity also uses real data recorded at 3 seismograph stations from an earthquake that occurred in 2011. The P and S wave first arrivals are indicated, and the time between those first arrivals at a given station indicates the distance between that station and the epicenter. So here's a map that students can use to estimate the epicenter location from that earthquake, which caused damage throughout the northeastern United States. In the instructor's manual, we include a link to an IRIS web app that allows you to do this same graphic analysis without drafting compasses. And since this is an actual earthquake, they can then go on the web and see how close they got. The part of the lab manual that I am most excited about is a new lab devoted to climate change. This is a topic that has been represented in several chapters in the last few editions, but the new 12th edition devotes an entire lab with 6 new lab activities supported by 4 new videos to climate change. I was motivated in suggesting that we include this new chapter by the question from an as yet unformed grandchild who asked me, "Grandpa, what did you do about climate change when you had a chance?" Well, I could easily fill a webinar with the story of how Mark Carpenter and I developed the climate change chapter. We focused on content that seemed like it belongs in a physical geology course and that could be supported with good laboratory activities. Plainly, there is a lot we can talk about concerning climate change. But in the end, Mark and I had to create lab activities that would help students understand important things about climates, past and present. We were not unaware of the political context in which this content will be received by teachers and students alike. Throughout the past century, many geology and geophysics students have pursued geoscience in order to get a good paying job in the oil business. And a reasonable number of teachers had prior careers in the oil business as well. The electricity that enables my participation in this webinar is produced by a new coal-fired electrical plant located about half an hour away from here. But in the words of Richard Feynman, reality must take precedence over public relations, for nature cannot be fooled. Our approach is to let the data do the talking and to let students experience reality through working with the best available relevant data. I consider the climate change chapter in the 12th edition to be our opening ante and expect this lab to evolve dynamically in future editions as our understanding and data sets improve. I hope that you folks watching this webinar will help us to achieve that positive evolution of this chapter so our students will be well informed and better able to make good decisions. Callan Bentley produced another fine pre-lab video for the Climate Lab, for which I'm quite grateful. We introduced students on how we measure change in ocean temperature and chemistry these days, using about 4,000 Argo robotic floats deployed across the world's oceans. We consider how we measure the volume of the great continental ice sheets using various geophysical techniques so that we can detect change. We let students see what the trends are for mass change of ice on the Greenland and Antarctic ice sheets and glaciers. Generally, the change involves a loss of ice mass. We introduce them to the network of tide gauges around the United States and show trends in measured local sea level change over time. We introduce students to ice cores that have supplied us with such amazing environmental data for the past 800,000 years. The time series that are most relevant to the climate issue over the past 800,000 years are compared in a single chart within the introductory text of the chapter. The time series include insolation, think Milankovitch cycles, surface temperature, global sea level, carbon dioxide, methane, deuterium, and oxygen isotopes from shells and marine cores. Each of those curves was produced by a mathematical code that I wrote to convert the original digital data sets into time series curves. These are real data. The vertical pink strips indicate interglacial warm periods. There are 6 activities in this chapter. In the first, students consider how warming the oceans might cause a change in sea level. I made a short video of an experiment that students can see on their smartphones. The various steps involved in the experiment are listed in the lab manual for teachers who want to actually do the experiment in lab. The video compresses the entire experiment into a couple of minutes. Here, the water level is noted at an initial temperature of 22.6 degrees centigrade. At the end of the experiment, the water is 6 degrees warmer, and the water level has risen in the glass tube. So, does raising the temperature of water change its volume? Students then work with a time series graph showing total global mean sea level change along the black curve, and the part of that total sea level change that is due to change in water temperature and salinity along the blue curve. The black curve is from satellite radar altimeter data, and the blue curve is from data collected by the Argo robotic floats. The next activity relates to how melting ice might affect global sea level. Two simple experiments are done to address the matter. First, does the melting of ice that's floating in water cause the water level to change? We have a 2-minute video showing ice floating in a beaker of colored water, and we observe what happens, sped up 50 times normal, as the ice melts. So, what do you think? Does melting ice that is floating in water cause a change in water level? The next experiment asks whether sea level changes when continental ice sheets and glaciers melt. We put some ice cubes on a screen above the beaker, and in a 2-minute video in which the experiment is sped up about 50 times normal, we see what the effect of melting those ice cubes has on the water level. Again, the steps needed to reproduce these experiments are listed in the lab book, but the videos help students complete the observations efficiently. As before, students work with a time series graph showing total global mean sea level change in black, and the part of that total sea level change that's due to melting of the Greenland and Antarctic ice sheets in orange. Adding the contributions from temperature and salinity changes in the world's ocean to the contributions from melting in Greenland and Antarctica accounts for most of the total global mean sea level change. The next activity utilizes an online app to investigate modeled changes in the local sea levels as measured by tide gauges operated by the USGS, NOAA, and other public agencies. These measure local variations in sea level due to regional subsidence or uplift. Then we look at the time series from the atmospheric concentration of carbon dioxide measured at the Mauna Loa Observatory in Hawaii. Again, these are faithful plots of real data available through Scripps and NOAA. Students are asked to sketch an average curve through the time series, which is based on direct sampling of the atmosphere since the late 1950s. Then we ask them to project their average curve forward in time to estimate what CO2 levels might be in the future if current trends persist. Then students work with CO2 data from ice cores up to about 1960. And then they add the Keeling curve from Mauna Loa to extend the green CO2 curve for the years since 1960. In the fifth activity, students look at the CO2 and methane data from ice cores and the associated global mean surface temperature data to understand their temporal correlation and explore the changes in the curves since 1992. The last activity considers how sea level rise will affect several coastal areas in the United States using NOAA's Sea Level Rise Viewer. Students work with inundation models of San Francisco, New York, New Jersey, New Orleans, Portland, Naples, Florida, and Charleston. For example, here's a map of Naples, Florida today. This view extends from about Fort Myers in the north to Marco Island in the south, with Naples about halfway between the two. And here's a model prediction of what the coastline near Naples will look like with mean sea level about 1.8 meters higher. In the high intermediate scenario adapted by NOAA from a US federal climate working group, this level of inundation is expected to be reached in the year 2100, about 80 years from now. It's pretty startling. So in summary, the new edition of the AGI NAGT lab manual is now in print and available for course adoption. Royalties from sales of the lab manual help to fund the activities of two organizations that are very important to us all, NAGT and AGI. The new edition has a new laboratory chapter that's focused on the geological processes and evidence associated with our changing climate. The lab manual is available in the traditional paper format as an e-text as of the Memorial Day weekend, I'm told, and as a customized textbook, and is supported by a revised instructor's manual and mastering geology. The primary literature and data references used to develop the laboratory chapters is listed in the instructor's manual. So teachers can request a copy of the new 12th edition of the lab manual and access to the instructor's manual by contacting your Pearson Higher Education rep. To find your rep, just go to the URL that I've put up here, and I'll be happy to send this URL out to you after the webinar. We also want to hear from you as you review and use the lab manual's 12th edition. What are your ideas and suggestions for the future? The continued improvement and future evolution of this lab manual is as much a community responsibility as was its creation more than 3 decades ago. I would love to have you help us in this process. So my email is vince_cronin@baylor.edu. So thank you for your attention. I think we have time for some questions and comments and so forth. So let me just get my video thing turned back on here, and we will keep going here. Okay.
Thanks, Vince. We did get a couple of questions in the chat that I'm happy to read off. One of the first ones was whether or not the e-text is readable using assistive technology.
I'm going to have to bat that over to
Vince,
Tom
yeah,
Hoff.
I got you on that one. So for those who are on, I'm Vince's editor. There's other team members from Pearson on. Some of us have been answering questions. The answer to that question is yes, it is readable by assistive technology, excuse me.
And then another related to accessibility is whether or not the lab videos are available on DVD for those who can't access them via the internet.
As of right now, no, but that is one. I'm going to actually put my email in the chat after this. Let's see if there's something that, because I know that these are such weird times, and I know that that question was specifically for a correctional facility, I believe. So I'll put my email and let's see if there's something that we can try and figure out for you. As of right now, not exactly.
So let me pop in here. I'm just like all the rest of you. I am a newly minted distance teacher. And so I use this lab book, currently using the 11th edition and about to start with the 12th edition for the summer. And as I develop things that relate to this lab book, I am going to make those things available through my website. And again, I'll put that out there for all of you folks who are listening to the webinar, and we'll publish it in other ways as well. So I think as a community of users, we can help each other out. So what do I mean by resources that I'm going to be making? Well, you know, if you're doing these labs as a distance learning thing, Perhaps you don't have teaching assistants who are right there to answer questions as they pop up. But as students interact with me, I will be collecting those questions and trying to find the very best way of answering questions, because if one student is brave enough to ask me, you know there have to be hundreds who are not brave enough to ask me. So I'll be making little, 1 minute, 2 minute, 3 minute videos. And for the time being, putting them up, probably up on my website, probably migrating them up to the CERC website over time. And as we move forward, these sorts of things will become more and more prevalent in the formal lab book. But I'm all ears for people who have suggestions for things that they would like me to work on. Okay. Do we have other questions?
Yeah, there are a bunch coming in through the chat, and some are getting answered in real time. So I'm trying to find some that haven't been answered yet. It might be worth talking about the, there are some questions about mail-in sample kits that came into the chat and whether or not those are available for students, and if so, what the cost is. And I know that's answered in the chat, but it might be worth for those who either can't see the chat or are listening to the webinar afterwards to hear a little bit about that.
Yeah, sure. So not as of right now, just because I unfortunately we didn't really prepare for a global pandemic when creating the book. But I mean that is a fantastic idea. So that's yet another thing. I'm actually typing in right now what my email is. So please feel free to ask about that. Any suggestions? Any type of thing we can do.
So I know of some individual institutions who oftentimes through interactions with their alumni have put together these sample kits that they send out when somebody signs up for their course. And oftentimes there's like a slight user fee that gets refunded to the student if they send the sample kits back intact. I'm also told that Wards has for years put together little sample kits that are really specifically tuned to the kinds of specimens that we use in our lab book and that are common in other lab books. So that's a purchase thing rather than a lending thing. I'll also say, and my wife will possibly want to stuff something in my mouth after this, but when I last moved, which was from Wisconsin down to Waco, I came with 96 boxes of rocks. And that was, 2002, I think. And I'm pretty sure that I have at least that many more rocks. So if I can help anybody out who needs to borrow a few rocks, just give me a holler. Now, I'm aware of that because where I'm sitting right now is in Waco, Texas, and there are lots of different kinds of rocks that I don't have easy access to, say, during a one-day drive from Waco. And a lot of people are in that same boat. Now, I know that NAGT has organized some rock sharing efforts in the future, but we can certainly amp this up as we all face these challenges that we didn't really think we were going to be facing. So just let me know how I can help.
Yeah, there could certainly be ways that we could get that involved with NAGT's rock and mineral exchange.
Right.
Another question that came in that maybe you might have some insights on is how students might turn in answers if in times like right now when things are completely online and might not be able to you might not be able to get the physical answer sheets themselves.
Right. So I can tell you what I'm doing right now. You know, normally you could just say, you know, just tear the answer sheets out and send them to me. Problem is that having a physical thing coming from a student who may be a little bit sick with COVID back to the TAs, well, that's a liability that I'm not willing to take. So since spring break, I have been creating Word documents that contain basically all of the questions in a given chapter. And to the extent that there are word answers, I give them a place where they insert their answer. Where there are situations where a student has to draw on an illustration and that is the nature of their answer, I've taught them how to take pictures of their drawing using their smartphone and then inserting the picture as a graphic into this Word document, and then they just send the whole thing in. Initially, I thought, well, I'll just have them scan the whole thing, but you know, the file sizes of scanned completed answer sheets would just crush my TA's inboxes and so forth. So that turned out not to be viable. Again, you know, with permission from AGI and Pearson, I'm happy to put those Word documents with hints about how to fill in the answers online for students to, or for you folks to modify and adapt for your own classes. Now, as I said, I'm going to be using the lab manual through the first summer term, so I'll be generating more of those things over the next month or so. So that's kind of the short-term emergency way of doing it. Longer term, what we're going to do is sort of up our game with respect to the e-text and have documents available through Mastering Geology for the lab manual that will make it much easier for students to fill in a form with their answers or some such thing. So that it's quite high on our list of things to do, I would say. Tom may disagree with that, but
no,
I am painfully aware of this issue.
No, we're on board with that.
I'm willing to share anything that I have come up with anybody out there, and maybe we can all help each other through this.
Yeah, no, I'm on board with that fully. And of course, Vince, nobody knows the challenges of actually using this book for distance learning better than you. So,
you know, I found it a lot easier to use than I had anticipated, though, because so many of the activities are things where the student sits down, they read the introductory material, they have some questions to answer. There are good photographs or graphs to help them with it. The one thing that my students have commented, though, is how helpful it is to have a physical TA right there with you. So, you know, that's something that we're going to have to work on. Part of it is going to be creating some videos that will answer the questions they might have asked the TA. And part is just simply the clever use of chat rooms and so forth that you might be able to organize through your institution's learning management system. Or perhaps there are some opportunities for Pearson to do something through the Mastering Geology. But we're all ears on what sorts of things you think would help you to get over these humps.
So one potentially related question to some of the recent discussion came in about whether or not there is any development of integration between, say, the activity sheets and various learning management systems like Blackboard, Moodle, etc.
Yeah, well, I think that's the way we're going. I have used Blackboard, and I'm currently using something called Canvas. But ultimately, those answer sheets or some form of those answer sheets need to be converted to forms that students can use. And even if the forms are not completely machine gradable, if you can get some of the form in a state where it can be machine gradable, then whoever does the rest of the grading will have less work to do. But yeah, well, that's the target at the moment. We're quite focused on it, I would say.
Another question was, when will the instructor resources be available on mastering geology?
Sure.
Go ahead, Tom.
If you want, I can. Okay, yeah, I can handle that one. So this gives me a chance to kind of tackle a couple different questions that relate to the mastering and instructor manual. So the e-text and the mastering for this title are expected to be, like Vince said, around Memorial Day. It may be pushed slightly off just because so many things are in flux throughout the whole world right now. But we're highly anticipating that that should be ready to go. Obviously, way in time for back to school. The instructor resources, which is within the mastering as well, is also going to be ready at that time. That should be able to, and somebody else had asked about the JPEGs before, that is actually found in the instructor resources part of this as well. So that should be ready to go. I'm trying to see if there's any other questions. And yes, somebody asks, is the 11th edition good to go for courses starting this spring? So yes, the 11th edition is the one that's already been out. And the 11th edition is actually free. One thing I'm not sure if this had been publicized, but because of all this going on, Pearson is offering free e-text access until July 1st with books that have currently been in use for this spring semester itself. So that does not include the new 12E AGI lab manual, but if you did want to get a little bit of a look at, how this franchise itself would look overall in the e-text, again, that is freely available for the 11E specifically until July 1st. And then of course starting for all fall semester, then you'll be able to order the book, the e-text mastering for the fall. But, so again, the book is ready to go, it's ready to be shipped, it's ready to be ordered. The e-text and the mastering and the instructor resources that come along with all that are around Memorial Day. Accessing the free e-text, somebody just mentioned that. The best thing to do right now is to go directly to the rep, because the rep is going to be, it's to go exactly to your school's rep, because the rep is going to be able to keep track of exactly which schools have gotten the free e-text access and how that's going as well. So that's the best way to go in order to get the access for the 11U right now. So sorry, Mitchell, I just want to knock out a couple questions that all center on the same theme.
Oh no, that's perfect. One thing that I don't think has come up, but for an uninitiated user, was one question that I had, was how someone would go about customizing the laboratory manual. I think it was mentioned that it can be modified for specific use.
Well, I have done this myself. So I picked, in a given semester, I might have 10 labs, space for 10 labs. But a couple of the labs, I have something that I really wanted to do, a stream table experiment, a little short field trip or something or another. And in that situation, I just didn't feel good about having a student buy a book where I knew to start with they were only going to use maybe 40% of the book. So what I did was I ordered up the chapters that I did want to use from the book. And I think in that case, I might have ordered 8 chapters. And Pearson binds the 8 chapters together. It's not printed on the sort of high gloss paper of the normal lab book, but it's still printed at high resolution. And they ask you to supply a cover picture, or if you don't have a cover picture, like a picture of your cat or something, they'll supply a nice tasteful cover, and they'll ship it out to your bookstore, your department, whatever. So, there's a sort of a cost benefit analysis to this. Once you are using maybe 10 or 11 chapters out of the lab book, it's probably just as well to buy the entire lab book. But if you're only using a few, then the custom route is a good way to go. The other thing I would say is that sometimes people have decided to just simply go the route of just simply making their own lab book. And that's fine, but oftentimes the photo coverage isn't as good as you could possibly have. The reproduction isn't very good. In order to keep costs down, you might go with just a black and white reproduction. And when you add up all of those sorts of things, I think that there are some chapters in the NAGT AGI lab book that you should really consider buying and then build your own lab book around them. Okay. So maybe there, in a given course, you have a little volume that is the homemade stuff and another little volume that is made up of chapters from the AGI and NAGT lab book. That's fine. Students can figure that out. The thing is that as soon as somebody orders even a single chapter from the NAGT AGI lab book, that generates royalties for NAGT and AGI. So it's a good thing to let us help you with some of the chapters that you don't want to do on your own.
A related question just came in. Can the customized version be exclusively the exercise pages?
At this instant, we don't have that available, but this is another thing that we have actively talked about. So all I can say is stay tuned, because how this resource evolves is partly a decision by AGI and NAGT and Pearson, but those decisions are driven by the community. So if that's a community resource that people want, I think we will supply something like that. Now, could we supply it for this coming academic year? Well, that I don't know about, but it's certainly something we can put in the can for action as quickly as we can. I'm not really on the publishing end of this. I'm more the content editor, but I myself have thought of that very same need. And the reason is that it's easy enough to read the introductory material in an online textbook. Having the paper copies of the activities, that's a benefit. So, yeah, perhaps we'll go that way.
I think that's it for questions in the chat. Maybe we'll leave another minute in case anyone's got another question, or if your question got buried in the chat, feel free to send it through again.
Well, inevitably, people are going to, go back to their caves, and somewhere in the middle of the night, they'll think, I wish I had asked that guy, whatever. Well, don't hold it in, because that's bad for your mental health. What I want you to do is get my email and send me an email message, and I'll be happy to answer your question or get it to somebody who can answer the question. Because again, this is a community effort, and I will happily do what I can to help you.
I think you had a slide that had your email on it. Do you want to back up a few so that people can write that down?
Well, let me see if I can actually accomplish that feat. Oops.
You might, yeah, that'll be fine.
Okay, so can you all see that?
Perfect. And there was also a question about what the URL for, you said you had a website that you'd be posting some things on.
Yeah, I haven't made that yet. I've got a website that has, I don't know, it's not quite as bad as CERT, but it's got thousands of things on it. So I'm going to make something specific for this purpose, and I haven't done it yet. But I will, we have records of who signed up for this webinar, and I will get information about that out to you directly as soon as I can.
And we could also post that kind of information on the webpage for this
Yeah.
particular webinar.
Yeah, that's good.
All right, well, we are pretty much out of time. So thank you, Vince, for spending an hour to tell us about the lab manual. Thank you everyone else for participating in today's webinar and asking some great questions. We always encourage you to check out the NAGT webinar series for our future upcoming webinars. And if you're able, take a few minutes to fill out our webinar survey to help us get input and improvements from you all. So thank you again, Vince. Thank you, Tom, for assisting with some of the questions. And thank you everyone for joining us.